What's going on, everybody? Welcome to What Up Clay, the channel we talk about all kinds of things, how to fix things, build things, as well as maintain things, and product review. Today we're going to do the product review, and we're going to do, you've probably seen the video already where I did the review and testing of the, basically the dissecting of the Reds Racing, the standard version. Brushless motor 17.5T, this is the VX4. In this video here, I'm going to run it on the Jerry. This again is the Jerry 3.0, the newest version. You can find these at wmhracing.com. Anyhow, let's say we slap this on the Jerry and go learn something. So, what we're going to do on the Jerry, we're going to run the, again, this is Red Racing, the Gen 4 VX4 17.5T. This is a standard stock motor. It's not the factory select. I do have, boom, right there, look at that, the factory select. This is going to be my next video that I do. Red Racing, the factory select version of this. This right here is a, if you saw my other video where I reviewed this, it is a pretty high RPM motor. It's just over 23,000 RPM unloaded. It's about 21,300 or something like that loaded. And that's being run on the Loadmaster. So we're going to run this on the Jerry. I'm going to have the Surpass V6, the Fat Boy, is going to be the slave motor up here on this side. And I'm going to have all my gears right here. I'm going to run it through the gears and see how this thing does under a load, and then I'm going to compare it with the other motors that I've done and see how, basically how it compares when it's being put under a heavy load. Alright, let me get this inside the machine and put the gears on them and get them ready to go. Okay, so I have it all loaded on. Have the VX4 over here, the Reds Racing over here. I have the Surpass on this side. The Surpass is going to be the load motor. Same motor I use in all the other tests. First we're going to do an auto test, see the numbers of it. Then after that we're going to do a 20-second run. And during that 20-second run, I'm going to check the speed of this motor by using the laser tachometer. I'm going to check to see how fast the load motor is spinning. And then I'm going to take the temperature of it. And right now we have the 27 tooth pinion gear on there. Now if you're wondering why I use this right here to take the temperature versus the onboard temp sensors, because not all motors have a temp sensor. For example, this right here doesn't have a temperature sensor on it, and the Reedy SP5 does not have a sensor motor or a temp sensor on it as well. So to keep everything as apples to apples, use the laser gun here. So it is kind of warm in here. Just shot that. Let's see, right now it's 83 degrees in here. I just shot the temperature of this. It's 83. It is warm in here. I need to turn the AC on. Anyways, let's go ahead and start the auto run. Alright, 1116 amps, 28, I don't know if you see that there, 11.16 amps, 2891 kV. Then you have the numbers over here. See, I was seeing 32 degrees. That means there's no sensor, there's no temp sensor in the motor. So, because it's definitely not 32 degrees in here. Let's go ahead and run the auto mode. We'll do a 20-second run. And get my timer set up here. Okay. 20-second run starts now. All right, there you go. Let's go ahead and put the 28 tooth on there now, and well, let's check the temperature first. The temperature, I'm reading as 100 degrees, 101. So, all right, 28 tooth next. Okay, I have the 28 tooth pinion loaded on here. So you're aware, you're probably wondering where the resistors are for this motor. If you remember right, the Jerry for the load motor and the load for the load master, and for this side here for the load motor, it's connected to resistors, either 1 ohm or 2 ohms. The resistors are inside of this. You see the contacts in the bottom? Well, the resistors are inside here, so it's nice and compact. To swap them out, you're gonna have to take the top off, which means you have to take these feet off and take the screws out, but really there's no reason to swap those out. So let's go ahead and start this. We'll do the auto run first. All right, run 11.33 amps. That's not very many amps, more than what it was last time. It was 11.16 if I remember right. kV is 2885, and then I have 44.8, and then the rest of it here, nothing changed, as you can see there. All right, let's go ahead and do a RPM run and 20-second run. Let me get my timer ready. Okay, on your mark, get set, go. All right, let's go ahead and put the 29 tooth in now. After I take the temperature. $105. Let's see what the can is. Can's 100 degrees. The back of the can, which is where I normally take the temperature. All right, 29 tooth is next. Okay, we have the 29 tooth on deck. Let's go ahead and do the auto run. Wow, it dropped big time in current. 10.86 amps, 2900 kV, and a 45 degree bell timing. Anything here changed? Nothing there changed. That was a big drop, and that was what, from 11 something, 1166 to 1086. Almost 1 amp drop. Okay, let's go ahead and run a kV. I mean, not kV. Let's run an amperage or RPM on it. 20-second run. Get our timer set up here. Ready, set, go. All right. Take temp. 113 degrees back there. Back here it is 105 back there. 107. So let's go ahead and put the 30 tooth on it. Alright, 30 tooth. Let's go ahead and run auto. .56 amps, 2827 kV, 44.5 degrees. Nothing here has changed. Let's go ahead and run an RPM test. Okay, let's get ready and start. Can temp. Can temp's 113 degrees. .31 tooth is next. Okay, 31 tooth. We have two more to go after this. We have the 32 tooth and the 40 something tooth. I can't remember what it is. 41 tooth. So right now is the 31 tooth. Auto run. .8 amps, 2860 kV, 44.7 degrees. And of course nothing over here changed. Well, this one right here went down to 2.0 versus the 2.1 on the rotor symmetry, and 0.6 on the M-bell deviation. But the Hall signal deviation is still at 2.1. Okay, now for the RPM. Okay, ready, set, go. .114 degrees. You see that there? 114 degrees. All right. 32 tooth is up. 32 tooth now loaded. .26 amps, 2844 kV, and 44.6. So everything here is still kind of the same. My tuner light is getting a little warm. Okay, let's go ahead and run the timed run here. Okay, ready, set, go. Okay, and I get temperature on that there. The temperature is so you get the right temperature here. About 116. Alright, next one is the big boy pinion gear, the 42 tooth or 41 tooth. Alright, let's get that one up next. 32 tooth, now loaded. .26 amps, 2844 kV, and 44.6. So everything here is still kind of the same. My tuna light is getting a little warm. Okay, let's go ahead and run the timed run here. Okay, ready, set, go. Okay, and I get temperature on that there. The temperature is so you get the right temperature here. About 116. Alright, next one is the big boy pinion gear, the 42 tooth or 41 tooth. Alright, let's get that one up next. Alright, now we have the 41 tooth in there. This is the test of all the tests. Separate the big boys from the little boys. So one reason why I do, if you're wondering why I just don't go straight to the RPMs, I do the auto test because when the auto test goes through different stages of starting and stopping and stuff like that, a low torque motor, which you've seen in my videos, been watching my videos, I have one motor that did it. When it starts to low speed, it'll start to get going and it'll just stall, it won't get going. I have to like give a little bit of a kick to get it to go. So anyhow, remember this is a high RPM motor. So let's hope that it has the torque and doesn't do any hesitation here. Otherwise that'd just be embarrassing. Not for me, but anyhow, here we go. Seem to run all those tests pretty good. 15.4 amps. That's not bad at all. 2703 kV. 7.4 volts, of course. 43.8 timing. 0.6, 2.1, 2.1. So everything there is the same. See that there? I want to go back to there. I don't know if you can see that in the picture here. Try to do without a glare. So 15.4, 2703. Okay, now we'll do the RPM test. On your mark, get set, go. Okay, that concludes that. Let's go ahead and take the numbers, put them on the spreadsheet, and then we'll compare them to the other motors, and then I will give you my final thoughts. First, I'm going to take a tip reading. Temperature actually went down. 113. Let's see what that the plate is inside. The inside is 119.5, but the can itself is 117. So let's go ahead and yeah, let's put the numbers on the spreadsheet and see how it compares. Okay, here's the numbers on the spreadsheet. For the Res Racing VX4 Standard 17.5, free spinning without any load on the motor itself, it ran 24,511. I think before I misspoke by saying it's 23,000. It's actually 24,511. 5.6 amps, so on. You see the numbers there. So with a 27 tooth, it spun the load motor at 19,469 RPMs, 11.16 amps, and the temperatures. 28 tooth, it went to 20,164, 1133, and then let's see, it dropped down when I put the 29 tooth on. It dropped down in amperage, but it went up almost 1,000 RPMs. 863 RPMs to be exact. And then this right here, I must have had my gapping wrong. I do the whole cellophane trick with all my gapping. I don't see why this is that way. This should have been probably in the neighborhood of about 11.4 amps, and this should have been somewhere around 21,500, somewhere around there. Because this right here, I was looking at it over and over again. It doesn't make any sense. The only thing I can think of, like I said, I must have the gap wrong or something. But let's see, we have 11.8, 12. Now, how do these numbers compare? 27,657, that's pretty fast. How do they compare? Let's take a look. 5,000 RPM jump up right there. That's huge. Let's take a look. So this is the double down. We can't really compare to that because the double down, it's an outlaw motor. Shouldn't be comparing that one, but it's on here anyway just for giggles. Just to show you the numbers that can happen if you have an outlaw motor. Let's see, we go to the slot machine 2, or the slot machine. 27,521. This right here, the V6, the VX4, the Red Racing, was 100 RPMs faster, and it had 1 amp less draw. So I would say that it would be a better motor than the slot machine. And let's see, we go to the Surpass. The Surpass 27442. This is 200 RPMs faster, 15.4 amp draw, 15.56. Wow. It's showed to be faster than the higher RPMs than the Surpass at the same amperage, same temperature. If you see the temperatures, they're the same. And the RPMs are about 200 RPMs more. kV is almost 50 kV more. All right, let's see how it compares to the Exalt. It's about 400 RPMs faster than the Exalt. It's about the same amp draw and the same temperature. So here, 27,657, 15.4. 27 tooth 55. So how does it compare to the Hobby Wing? The Hobby Wing is 23,000. Well, I don't have the 41 tooth. I wish I would have had the 41 tooth when I had the Hobby Wing. But if you compare the 32 tooth, let's see how that compares. 1339, 2376. This is about 1200 RPM slower, but it's looks to me like, let's see, 1226 versus 1339. So it's 1.1 amp less draw, but it's 1200 RPM slower. So every time you gear this thing up, it goes up a little over 500 RPMs. Like you look here, it's 500 RPMs. Between here, it's about 6. So it's between 500 and 600 RPMs. So if you go up to 2 teeth, looks like this right here. You can go up 1 tooth. Is about a half an amp per tooth. Except for, I guess it says right here. So yeah, you can easily go up 2 teeth and you would be just passing the Hobby Wing at the same amp draw. Well, let's see. Then we have the Tekin G4R2, 12.18, and yeah, that one right there is probably going to be almost the same speed, but still not quite. Because this one right here is 12.26 and 1,000 RPMs faster than the G4, the Gen 4R2. So go ahead and take a quick look. Here's a screenshot here if you want to take a screenshot and compare. And also, if you remember right, with the Hobby Wing, when I did these two here, I had to give it a little, these two gears here, which one's the 28 and 29, I had to give the motor a little bit of a bump to spin. So where the Red Racing did not need a bump. Anyhow, the Red Racing VX4 Standard for $100, I would say, my personal opinion. Now, again, there's thousands of racers out there, so there's going to be thousands of different opinions on what these numbers mean. So my personal opinion would be that for $99, the VX4 would probably be, out of the motors I've tested, would probably be the better motor. I didn't flub any motor, any numbers, anything like that. All my tests you see right on video. So anyhow, hope you liked the video. Hope you learned something. If you liked the video, please hit the like and then also subscribe. And it helps me to be able to obtain more motors and support the channel. And if you didn't like the video, hit the like, subscribe anyway, so you can make fun of all my other videos. All right, everybody, you take care.